Video. Let's quickly go ahead and take a look at a question from our IB syllabus. You've previously learned that there's two types of quantities in physics. A quantity is anything that can be measured. Vector quantities are things that have basically magnitude and direction, like acceleration, velocity, force. Scalar quantities are the type of quantities in physics that do not have direction and they only have magnitude, like mass, time, speed, and distance. You can never specify direction for like something like time. Now, let's go ahead and take a look at this question, which is about vectors. Before you go ahead and actually really do this question, you need to have a good knowledge of trigonometry. So we have two vectors that are broken down. Basically, the question is asking us to break it down into the component of vectors, and the magnitudes of the A and B are given. So let's go ahead and try this now. Vector A, so let's draw this out in the x and y axis. Vector A is in the third quadrant, where both the values of the x value numbers and y value numbers are negative, and the angle at which it's being directed is 45 degrees. Now, in order to break it down into its components, I'm going to construct a line that goes vertically. That's going to be the direction of the vector in the y-axis. And then another one that goes in the x-axis. That's going to be the component of the vector in the x-axis. So, basically here, I can find AY by using the rules of trigonometry. I know that anytime any side is opposite to the angle, you can find that sign by using sinus. So AY is going to be equal to A times sinus of 45. But because A is in the third quadrant, it's going to be negative A times sinus of 45. Now, you can also say from the first quadrant to the second quadrant is 180 degrees. And since this side falls in the third, you can say 180 plus 45, that's 225. So you can also say A times sinus of 225. But they would both give you the same value. Now, if you were to go ahead and find AY is just going to be negative 12. That's the value of A times sinus of 45. And the value of that is equal to 12 times 45. Technically, negative 8.48. You can round it up to negative 8.49. Let's go ahead and take a look at AX now. AX is the side that's adjacent to 45 degrees as the angle. But the value of the x value in that direction is still negative. So you have to say negative A times cosinus of 45 degrees. So that's technically going to be equal to negative 12 times cosinus of 45 degrees. So AX is equal to, again, negative 8.48, which I'm going to round up to negative 8.49. Now, if you were to kind of go ahead and calculate that using the angle, like the fact that that side's, in the third quadrant, you would still get the same value. So you can still find it by simply multiplying 12 by the sinus of 225. But you're going to get some messy numbers and angles, and sometimes you can make mistakes in that. It's just better to use the fact that A is in the third quadrant, so its x and y value are going to be negative. Now, for component B, B is actually going to be broken down into two angles as well. Now, keep in mind that B is in the fourth quadrant, where the value of the y values are actually negative, but x values are positive. Now, here's going to be the component of B in the y-axis, so that's by. And the component of the vector in the x-axis is going to look something like this. We're going to call that bx. So let's scroll down and try doing this. Bx is going to be basically found by, now keep in mind that bx is in the fourth quadrant where the values of x's are positive. So you can say positive b, and it's also adjacent to 30 degrees as an angle, as a side. So we can say b multiplied by cosinus of 30 degrees. Anytime the angle is adjacent, it takes cosinus. Anytime it's opposite, it takes sinus. So 30 degrees is opposite. We can say by is going to be negative b because the values of b numbers in the y-axis are negative times the sinus of 30. So we know that b is 24, so 24 times cosinus of 30 degrees, and negative 24 times sinus of 30 degrees. And so 24 cosinus of 30 is equal to 20.78, and negative 24 times sinus of 30 is equal to negative 12. And that's it. That's how you can find the components of vectors in the x and y axis. Now, if you're wondering how I'm getting the fact that the opposite side always takes sinus and the adjacent always takes cosinus, that's from SOHCAHTOA 12. You've previously learned that if you have a triangle, let's say even like this, if this side is theta, and let's say this side is x and this side is, let me provide you with actual numbers. Actually, let's call that x, and then the hypotenuse is y, and then the adjacent is z. Well, if you want to find the sinus of theta, we can have basically the opposite over hypotenuse, because we know sinus is so, which means opposite over hypotenuse. Now, the opposite side to theta is x, so we can say sinus of theta is x over the hypotenuse, which is y. Now you can rearrange this for x, and x will simply be y times sinus of theta. So that's kind of how we're figuring out the fact that anytime the angle is opposite to that side, we can find that side by using sinus. And anytime it's adjacent, we can find it using cosinus. Let's take a look at another question. This time it says find the components of the vector. And this is a very common problem in the incline step problems that you see in dynamics. So we're trying to find the components of the vector. We have this incline slope. Let me draw that better. So we have this sort of incline problem. This angle here is theta. Usually there will be like a mass on this slope, and you're supposed to just find out the components of vectors on the mass. So we can draw a perpendicular line to this mass, and this line over here, which is going down, is the weight of the mass, which is denoted by W. Now, W is getting applied by a specific angle. We can call that angle theta. It's going to have two components. One in the y direction, we can call that WY, and one in the x direction, so we're going to connect that to the other side, we can call that WX. Now, WY is, as you can see, actually adjacent to the angle, right? And we said anytime the angle is adjacent, we can actually find the component of that vector by taking cosinus. So WY is just going to be W multiplied by cosinus of theta. And that's because we're taking the cosinus of theta. Cosinus of theta over here is going to be equal to the adjacent side, which is WY, over the hypotenuse, which is W. So we can rearrange that to get the equation I wrote at the beginning. Now, at the same time, WX can be found simply by going ahead and taking the sinus. So WX is going to be equal to W times the sinus of theta. Now keep in mind that the components of the vectors we have found are actually the things that can be used to calculate many different calculations. But at the same time, it's also remember that if you notice in the shape that is given, W is getting applied in the third quadrant, where the values of x and y are both negative. So we have to make sure that we put a negative behind the W's by hand, so we get the correct value. Or you can actually find out the theta in that quadrant by adding 180 degrees to the angle that is given. For example, if this angle was 30 degrees, you have to add 180 degrees to 30 degrees, just like in the first problem. And that would give you a value of 210 degrees. That way, your components would have correct values, and you will have the correct number. All right, thank you for watching. Stay tuned for more videos. Make sure you do a lot of practices on these. And don't forget to subscribe for future videos. Take care for now. Bye-bye.